Welcome, everybody, to episode number 11 of Baseline Tech Talk Tuesday. You've got the usual suspects here, myself, Andy Humphrey, RSM for the Northeast, Dan Conger, National Training Manager, Chris Wright, VP of Sales, and today we have a special guest, Lisa Rienstra, RSM in the Southwest states. And the topic for today is going to be using the BaseStation 3200 as a total site manager, i.e. using it for components that are not irrigation related. So Dan will take us from the top. I would like to remind everyone that you can visit the YouTube channel, which is Baseline Web Training on YouTube. So go to YouTube and search Baseline Web Training. And you can watch all the previous recorded episodes and catch up to where we are today. So thank you for joining. And Dan, why don't you kick us off?
Very good. Before you do that, Andy, will you turn on my screen sharing and let me do that? So that's always the trick, right? Is to make sure every Zoom meeting that you get the settings right. So, but as Andy's letting on, we're going to be talking about the BaseStation 3200 and letting it run things other than irrigation. So we know what it can do for irrigation, but let's talk about what it can do other than that. So I'm going to bring up my screen share. Realistically, we're talking about non-irrigation items here. So some three easy things to talk about is lighting. So lighting might be field lighting, like sports stadium type lighting. It might be high voltage path lighting. It might even be low voltage lighting. We could be talking about door locks for bathrooms or gates, anything electronic, or usually they're electromagnetic. It might be water features, so fountains, splash pads, pond aerators. But pretty much anything else that's electrically run, we're not going to actually run it, but we're going to run a program and we can schedule them and essentially manage them through our BaseStation 3200. So I'm going to ask Lisa to, there we go. I'm going to ask Lisa to share a little bit of background information about the site we're going to be talking about today. So, Lisa, what can you tell us?
This is a large city park in Arizona that is a 205-acre park with new soccer fields going on that kind of southwest corner that you see where it's farm fields, and more to come after that. But right now what we're kind of discussing is the old conventional system of the existing site. And we have, they had less than 400 zones at this site. So we were, minus the new soccer complex, but so we were able to retrofit this site out to with two 3200s and about 11 substations because the previous system had a lot of remote little 16 zone units all the way, around the whole site. So we just used our wireless substation and picked up items from lighting, door locks, and then irrigation at this site.
So it looks like they've got some tennis courts and some ball fields and general park and parking lots and maybe a couple of buildings there. Pretty involved.
There's a full-blown rec center on the north and another tennis court center on the southeast. Yeah, and lots of playgrounds and play structures as well.
Cool. So why was it so important to them, or why did they want to run the lights and the door locks as opposed to some other method of controlling them?
It's a good question. Every city is different. This city, the Parks Department actually does manage lights, door locks, and so it was already incorporated in the original system, which we were easily able to take over and retrofit out. But it definitely streamlines everything. They can, access lighting and everything with our system remotely where they couldn't with their old system. And, so it's just been a very convenient system for them to be able to retrofit over to.
So then it sounds like some cities, and this makes sense, some cities might have a completely different, somebody else might run the lights, somebody else might do the door locks, but in this case, the Parks and Rec, or the parks, that's them. And they're familiar with the BaseStation 3200 and what it can do. So I could see the familiarity being a really good idea there.
And just fewer, overall fewer control systems to have to operate and manage too, right?
Yeah. So in general concepts, that's going to reiterate some of what you just said, is some of the why is that we know that our controller is capable of running more than irrigation. So because we can, I guess is maybe the short answer. You alluded to this one less control system, right? So it's going to simplify the site management and maybe allow you to upgrade that crusty old Intermatic timer down there, the ones that you wish they would die, but they don't. It's amazing how long those things will kick. And if you really want to get fancy, you can add 2 more pins and have 2 ons and 2 offs. Ooh, slow down there. There's some time savings that's going to come in, right? We don't have to make a trip out to the site to adjust lights or to unlock the bathrooms. There's probably some labor savings, and if we don't have to roll a truck out there. And the other one that you mentioned was we have remote and mobile access. So you can change programming for, just like irrigation, you can change the programming for your lights or door locks or fountains from your office. But also that phone that you've been using as your irrigation remote now is a lighting remote. So if somebody says, hey, we're having a festival in the park Saturday and the bathrooms are still locked, like, oh, forgot about that. You can do that remotely through your phone and not even have to make a trip out there and just make your life a lot simpler. So I think it's summarizing what you just said.
Yeah.
So let's take a peek at some of the hardware you would need to do this. And I think one of the integral things here is a low voltage relay to switch that high volt. So let me just define what a relay is and what it does for those that aren't familiar with them. A relay is a electromagnetic switch. So it's going to take a low voltage power in, generally 24 volts on the input side, and then switch a higher voltage on the outlet side. So current doesn't actually pass through it. We've got our closed 24 volt system and then a closed 110 or a closed 220. So whatever the voltage is that you're running. So if it's a pump, it might be running 120. Maybe it's a 220 pump, or maybe it's a 230 lighting or whatever that is. So to make sure you get the right relay and we're starting messing around with high voltage, this is where a licensed electrician will really help you with it, right? They'll help you figure out the right relay and they'll make sure you can do it and be safe. On the irrigation side, we're very comfortable with low voltage. There's no licensing required for that, but high voltage, right, let's bring an electrician in for that one. But a relay is always integral. The other thing we're going to need on hardware is if you have a conventional wire system with a common and station wire, you're going to need an open terminal on that power bicoder. So you can see I have terminal 11 and terminal 12 are open. Great, we can use that to connect into. And if we're using 2-wire, we need a available zone bicoder. So here I've got a 4-zone bicoder. So all I need is the common white and the orange, which would run to my relay. Now I have the yellow, green, and blue available for other solenoids or for other relays, or for irrigation solenoids. So we have options on that, but I need one or the other depending upon the wiring we have out there. Now, does anyone want to wonder if there's any issues on where we connect up the relays? Because Lisa, you just ran into this, didn't you?
Yeah, no, absolutely. I mean, we've done this on conventional retrofits, and typically when I have had them, they have irrigation and lighting in one. Well, this time, since they were lighting only and just a handful of zones, they actually put them on posts 1 and 2 and called up and said, why are my lights at night going on and then off and then on and then off? And come to find out, actually, that's where actually on our conventional system, the first 2 posts are for the zones in irrigation that are associated to moisture sensors. That's their spot on the board. So it's constantly putting out and searching for the soil moisture sensing. So it does flicker. So we've moved those up to different posts.
So in fact, it was doing exactly what it's supposed to do. It's going to check as you just said, check the soil moisture sensor, and during that check, it has the opportunity to flicker or interrupt what you're doing. So it was just a simple matter of moving it from off of A1 and A2 to A3 or A4 or any other terminal, and it was fine. The same. Right. So A1 and A2, B1 and B2 are the conventional wired terminal posts that will check for a soil moisture sensor.
Yep, those are the quote unquote magic terminals.
Yeah.
A1 and A2 are magic, and communication is sent across those 2 terminals and pulled on a set frequency to get that data out of that moisture sensor. And that's what Lisa was experiencing, a just brief interrupt, which was enough to turn the lights off.
Well, I know we're not talking about soil moisture sensors today, but that is pretty awesome that we can run a soil moisture sensor on a conventional wire board, and that A1, A2, B1, B2. As you said, I think that is kind of magic. The 2-wire, that makes sense, but be able to do over conventional, I'm impressed by that. Okay, so here I did a screen recording of our customer's program. So here I'm just going to let it run, and we'll see what comes up. So here on program 5, you can see it's got runtime. So this is the lighting program. So we're going to open this one up and take a look at it. They've got it named. So park lights, always a good idea to name programs, especially as we get into more and more programs. This is non-irrigation, so it's important we know what's going on. This has a runtime of 180 minutes or 3 hours. And here they've used a primary and linked, and it's a way to simplify scheduling and have one zone influence other zones. This starts at 7:30 p.m., runs every single day of the week for that 3 hours it runs. And then down below, they've excluded it out of the hydraulic concurrency because lights don't demand any flow from the main line, so we excluded that. And we ignored global conditions. So global condition might be a rain switch that would influence the entire system. Well, I don't want a rain switch to influence my lighting. If it rains that night, we still need our lights to run or whatever it is. So it's good to be able to opt those out of this lighting program.
I think another good thing too, Dan, is with the water windows on the previous screen, it indicated a weekly water window, meaning that the water window was the same for every day of the week.
Yeah.
If you're running lights and say you have adult kickball on Wednesday nights and you need the lights on just that night over the softball fields rather than the entire park or all the other fields, you could just have that lighting system on its own schedule that can operate and have an open window on just Wednesdays rather than every night of the week. So using some of the other advanced scheduling capabilities of the 3200 can help to accommodate different schedules that you may have for these other devices on the site as well.
Excellent. Excellent point. So that was our lighting program. Let's take a look at the door lock program. So this door lock program, scroll down and find that one. This one is program 20. And you notice there's a space in between there. It doesn't have to be zone program 9. This is named as well. Good idea. Runtime is 450 minutes, 7.5 hours this runs. And this starts, what's the start time? You need to scroll down. Looks like it starts at 10 o'clock or 10:30 every single night of the week. So that probably shuts off, looks like about 6 a.m. by my math. And on this one, they don't need the global conditions. They don't want the rain switch. And the same with the hydraulic concurrency. We've opted out of both of those. So very similar to the first one. But what I really wanted to look at was this 450 minutes, right? So this is running for 7.5 hours. So starting at 10:30, it energizes the door locks and runs them for 7.5 hours. Now, if you had different hardware that didn't, you might need to de-energize them for a certain period of time. So kind of like a normally open valve or a normally closed valve. But what's nice is you have the options of switching this around. So different hardware would mean you program it differently, but it's not an issue, right? So what you needed to do would to start it at 6 a.m. and shut it off at 10:30 at night if you had different door locks. So knowing the hardware that you're trying to run is going to determine your program. It's really only just something that you need to know about and then accommodate your program.
So Dan, would that be, right now we're calling it, we're energizing it to lock the door versus energizing it to unlock the door. So if it was running during the day, you might think of that as being the unlock program because lock is default and energized is unlocking them.
Absolutely right. Now, and since none of us really know about door locks, that isn't our specialty, maybe all of them are always default in the unlock position, but I don't know that. And maybe we're not talking door locks. Maybe we're talking something else. So, but my important thing is that we can do it either way. And to your point, that makes sense. Okay, what do we got next? So I think if we kind of summarize some of this one, some of the things that are unique about Baseline on running these systems is going to be that we have this zone concurrency. So we have many zones that we can run. So we can run up to 99 zones on a BaseStation 3200, 15 of those that could be irrigation, and everything else could be non-irrigation components up to the limit of the controller. So we don't have a particular limit. So in Lisa's case, she wanted to run 4 zones all at once, 4 of her lighting zones, and that no demand on hydraulics, but potential demand on the system. We've got a large number we can run on that one.
So Dan, if you had, just thinking of this site, if you had your traditional light tower, if you will, and you had 24 light towers on a site, and each light tower had its own control, we could turn on all 24 light towers at the same time.
And then still run irrigation as well.
And still run irrigation. Right. That's pretty amazing.
Yeah, because on this site, if you have your controller and 6 substations and 8 of those zones are lights and door locks, it doesn't give you much left for hydraulics, does it? So in this instance, it frees it all up with how that we have the controller developed and designed.
And you just bring up a good point, Lisa. It's important to recognize that everything we've been talking about has no demand on the hydraulics. So if my capacity is 100 gallons a minute because I have a 3-inch main line, lights or fountains or whatever has no impact on that. So I shouldn't count that in the hydraulics, and we allow you to opt out of that. So the global conditions, right? So if we've got a rain switch that's going to influence the controller, that's great for irrigated zones that maybe got some effective rainfall, but effective rainfall has no influence on door locks, has no influence on path lights or stadium lights. So let's opt out of that one. We want to be able to opt out. We've also got 99 different programs that we can use. So if I only had 4 programs and one of them is taken up with lighting, now that means that maybe I'm mixing my drip and my spray into the same program. Well, I don't want to have to make that compromise. I want to be able to separate them out. And as you found on that program 20 that I did on the door locks, I even gave it some space to show that it's not an irrigation. Maybe I want to push it further down the page to make absolutely sure that no one accidentally programs that for the default 10 minutes that people love to run spray heads for. 10 minutes on the lighting might be really weird.
Right. A lot of the guys will bring it just down to the last, 5, 10, zones of a 200 zone system.
Cool.
And the other question, as far as you look at the 99 programs, we talked about zone concurrency, but at a 3200 system, Andy, how many total zones can we run at once if all is, designed right?
Right. 99 zones,
99 zones.
15 of which can be irrigation. 85 or 84 can be non-irrigation.
Nice. Okay.
Yeah, obviously you're going to have an ultimate amp draw limitation, right? But different devices will draw different amperage. So if you do have a system that's large enough in the hydraulics to support 15 zones operating at one time or 15 solenoids, you may not get all 84 other available zones to operate, depending on the amp draw of those other devices as well. So there are some limitations, but it's broad enough where you could run up to 99 on one controller, or with the wireless options and having it connected to a substation, with each transformer, that will give you the ability to optimize and max out that concurrent operation of the 3200 and its programming.
Excellent.
Which is what was used on that site in Arizona, right, Lisa? They've got substations that are just dedicated to lighting or to locks without any irrigation on them.
Yep, combination, but yes, yeah.
Right. I think what's great is you're jumping to the one beyond is that those wireless options, and substation is a great way. So as it turns out on your site, Lisa, the lighting controls were nowhere near the controller. So
Right.
they weren't going to run wire across the park to be able to run the lighting, but the substation.
Right now on the new portion of the soccer fields they're developing, that's a brand new design. So a whole new 3200's going in over there, and it's all 2-wire, and the restrooms and all that, will be run off that same 2-wire path, same controller. But that's easy because we started from dirt. Whereas existing, you saw that site, lots of roadways and this and that.
Yeah.
So yeah, they had to use the wireless substations.
Yeah.
Okay, so we've got a couple of questions that have popped up, and let's just clarify real quick. One question was how do we interface the controller with the locks? Right. So again, using that relay switch, interfacing with the electromagnetic door locks, right?
Right.
Just explain again that interface and how it works.
Right. So the way a bathroom door lock, electromagnetic door lock would be, or depending upon the style, typically there's two magnetic faces that are going to meet together, and they're going to be stuck together until they're energized or de-energized, and allow them to separate. All right. So the door closes, and now we can't pull them apart. And that's something that you would purchase from a builder supply or wherever you get, right? And then there's going to be some sort of a transformer that's going to energize that. That's part of the system. And then to turn that off and on, there are lighting or door lock control systems. But what we're talking about is using a relay to energize their system or de-energize their system, and then connecting that relay into the BaseStation 3200 to allow, instead of a whole separate programming scenario, we now have programming within the Base Manager or the BaseStation 3200, which hopefully you're familiar with.
Perfect. Okay. What about troubleshooting capabilities and reporting of issues associated with lighting or door locks, etc.?
That's a good question. I mean, we're just basically on off. It's not like we're really doing any other type of event for troubleshooting like we can on the irrigation side. So Chris, do you know of anything else that they can do?
Well, thinking of the way our 2-wire works, diagnostics associated with it, if a device is not responding, then it would send us an alert or an alarm for us to address. And then if there is an open or a short associated with that device, we'd be notified of that as well. So it would report incidences as if it were irrigation related in the same terminology, but we would be able to analyze and be alerted of the electrical issues that may be associated in communicating to those devices.
Yeah, with those relays, essentially we would know if that relay has shorted, if it's got an open directly at that relay.
Yeah, to that point, you would get the information up to the relay and say that the relay reacted or didn't react. But beyond that, the other half of the relay, if the door locks opened or didn't open, that's a whole different, that you wouldn't be able to see that information. So,
All right. Very cool. Another great use of the BaseStation 3200.
Yeah, and I'll maybe just add a couple quick points of summary, because you could, in theory, do some of what we're talking about with any old irrigation controller.
Yeah.
And over the last 10 or 15 years, requests have come into Baseline for this, and so our engineers thought about what it would take to do it better and or do it right. And so some of the things that Dan listed on that last slide, sort of make it work with Baseline. Again, I just want to make sure that everybody remembers that disobeying those global commands is key, because you don't want the rain sensor to accidentally turn off your lights.
Sorry, nobody uses the bathroom last night because it rained.
So disobeying those global commands is big time, as well as the zone concurrency. You need those lights to come on regardless of how many zones are watering based on the hydraulic capacity of your system, because it has nothing to do with the lights or the door locks. And so we need to be able to separate those components from irrigation type devices. And just wanted to make sure everybody realized that this isn't just making an irrigation controller work for other components, but it was designed to do this in this way, not just piece together that we happen to make it work. It's really designed to do it.
Another great question come in that's kind of a segue from Brian Young. In using the decoders, would one use a regular 5201 decoder, or would we use an event bicoder or a coach's button before the
Oh my gosh, he's amazing.
That was like this little soft
Segue.
pitch, right?
I know.
That was perfect.
I told you.
This is great. I love it. We were just saying, hey, we need a teaser on this one. So you'd be using a standard zone bicoder for what we're talking about. But everything we talked about today was on a scheduled timed program. So what if we wanted to do on demand, right? So if we wanted to turn on those door lights, or excuse me, let's say the tennis court lights, we want the tennis court lights to come on only when someone is there on demand. Okay, so then we're talking an event bicoder, right? So now we're talking, this is a coach's button, which is an event bicoder and a switch, or we could have just the event bicoder and your own switch, depending upon what you're trying to do. With this, we could have this by the tennis courts, press the button, it sends a signal to the BaseStation 3200, and it activates the program, which would then activate the relay and turn on the lights for the period of time that you programmed, right? So I think this is a teaser, because there's a lot you can do with the event bicoders and what we call start, stop, pause conditions. For me, start, stop, pause conditions was my mind blown when I first started learning baseline. I remember sitting in a training and Chris started talking about, oh, what can't you do? So I want to do a whole nother webinar on start, stop, pause, and event bicoders, because there's a lot.
Right. It does not have to do with time.
Yeah.
Start time.
Yeah.
That's right.
On demand.
Awesome.
Beautiful.
Perfect.
Good. Any last questions from anyone out there before we wrap this up?
Can we use a daylight sensor for lighting controller paired with a weather underground weather station for sunset sunrise control?
Ooh.
Oh.
First portion of that, yes.
Yes.
We don't have a way to take sunrise or sunset as a data point
The astrological
as of
calendar.
today.
Weather
Right.
underground.
Yeah.
As of today.
That's my can't answer. Yeah, because what you have the potential of decreasing your lighting or decreasing your door lock based off of ET, which that doesn't sound right. But the first part is absolutely right.
Well, Weather Underground, I think, has an astrological calendar. Isn't that correct? So I think that question's been
it's
posed.
not a data point that we can use
Right.
as
Yeah,
an
Weather
input.
Station can. Good.
Yep.
All right. Very good.
All right.
Okay, so
Well,
what's
thank
the subject for next week, Dan?
Ooh, managing with pressure, which is actually what Lisa has a customer call she's going to be doing.
Yeah.
Right?
Love pressure.
Under pressure. I got that.
All right. Very good. Well, we look
Be our
forward to putting that together. Maybe we'll have a soundbite associated with it next week.
Yeah, a little theme music as we come on.
Little vanilla ice.
All right. Excellent. Well, thank you all. It's
All right.
it's bottom of the hour, so our 30 minutes is up, and we appreciate you participating. We'll see you all next week.
Okay.
Go out and have a
Thanks,
great
everyone.
Take
Bye,
care. All.
guys.
Bye now.
Thanks.